Hello everyone and welcome back. Today we're going to make this completely useless material. I can't imagine what you would use it for, except for as an exercise in doing a couple of things. First off, we're going to learn how to nest functions up within each other so that we can make reusable functions. And we're going to make this funky material. And the other thing we're going to do is we're going to use a lot of waves. There's, the wave function, it's something that comes in with Substance, and you can actually use it not just to move stuff around like these stars. We can change the amplitude and the frequency and all this other stuff. I'm going to also change the randomization of the sizes here. We've got a lot of stuff going on. It's a very busy little material. The other thing we can do with a wave is we can fix it so that things like colors can go through a range. And I'm using that wave here to limit the range of the color change, but at the same time it allows me to pick a spot where that range happens. So I can change the color, but I can change it in such a way that it actually, kind of has more than just one color going on. And I can kind of do the same thing with the scale here of this sort of weird stuff going on in the background. I'm scaling it up, but at the same time, the sizes of those things are kind of getting bigger and smaller. They're kind of cycling through that big small thing. And these are all things that we can do with this very simple wave function that comes with Substance. So it's a very woodstocky material. I thought because of the 50th anniversary, we can make some crazy stuff today. And let's get to it then. Okay. So we're back in Substance, and this is the actual material that we were just looking at. And if we take a look here in the package, we'll see that in addition to this main graph that we have here, which we've got the little graph icon there, we also have a bunch of standalone functions, and they have this little function graph over here. And these are things that I can reuse in any material that I make. They're going to show up when I look in my library. And if I was making another material, I could go ahead and type that into my library and I can pull it out and reuse it. Well, not here because it's a main graph. In any function graph, I could go ahead and I could pull that out and reuse it over and over again. And that's what we're going to do. So let's start by making a new substance, and we'll call this effect switches, and I'm going to switch that around because that's how I like it. And let's save that. And we're going to start, well, once we start on this main graph, we're going to start with this effects map. And if you've ever made effects maps with me before, you will know that we tend to kind of redo the same things over and over again. I'm hitting the space bar, quadrant, space bar, quadrant. So we're going to be putting our image on here. We might as well set it up. We're going to use an input image. But, I always put things on this color luminosity channel, and then we set variables and we send them to wherever we need them. And this way we don't have to keep scrolling back and forth. We've just got this one thing to worry about. And it seems that, for a lot of things, especially for effects maps, when I'm laying things out, I want random this, I want random that, I keep making the same things over and over again. So if we create these functions rather than redoing them each time we make an effects map, if we create standalone functions, it's like code snippets that we can just plonk into larger things that we make. And that's what we're going to do today. So we're going to start with the code snippets, and then we're going to start looking at how we can combine those code snippets with, different things we can do with waves. So let's start. I'm going to right click on my package and I'm going new substance function. And this immediately creates a new new function graph, but it's giving me an error message, and it's doing that because there's no output. I'm going to right click, I'm going to rename this. Let's start with rotation. I wanted a different name, so we FX rotation, and let's start adding some nodes. Now, I want to be able to rotate it according, I want to be able to animate it. In fact, I'm going to make all of these snippets, we're going to fix it so that they have the potential, if you want, to animate them. So I'm going to need a time. And, because we've been down this road before, we know that it runs too fast for what we like. So we're going to have to multiply it by something smaller. I chose 0.1, but I want to be able to use this in a bunch of different ways. So I really want to be able to have the option of putting in a different variable every time I use this function. And I can do that pretty much the same way that we use input parameters in the main graph. You also have the ability to put input parameters in the function graph. So we're not in a regular graph here, we're in a function graph, but we can still do input parameters. And it works basically the same way. The only difference is that there's no info here. It's just labels and identifiers. You can also, well, we're not going to need a group for this one. If you do groups here, well, I'll show you later. But the main thing to take away from this is that there's no values. There's no place to put like default values in here. So instead of default values, what you're doing is you are creating an input spot for those values to go. So let's just add a node here. It'll be more apparent I think if I illustrate this. So I created that input parameter for this function, and there it is. So I can multiply whatever my rotation speed, which is probably going to be a number between 0 and 1. And then I'm going to take that and I'm going to multiply it again by time. So if we wanted to animate, we need to put a number greater than 0 in here. If this number is 0, this thing doesn't move. And then we set this as the output node. Now, if we come back to our main graph here, we now have this brand new function in our list. So we'll go into our effects map and we can start building this function. I'm going to click on that, we're going to edit it, and I can immediately drag in my rotation. And there is that input parameter that I put in here. So we come back in here and we double click on the graph, that's the label I created for it, and that's the identifier. So I can put a constant in here, or I can come back into my main graph and create an input parameter here, and then grab up another variable in here, and that can now be my rotation speed. But what we haven't done is we haven't actually set any variables here. We're still on the color luminosity. So we're going to need to set a variable, and we'll set this to rotation. I'm going to copy this just so I don't make any typos. And because we need to finish this up with the number 1, I'm going to get a sequence. And first it's going to run this stuff, and then it's going to give us the luminosity that belongs in this channel. And let's find something to plug in here. I'll just go ahead and use the thing I used before, and we'll turn that into a grayscale, and there we go. So even though in this graph here, in this function here, we don't have a $ time, it's living in this FX rotation. So if I come back in here and we publish this out, oops, something's wrong. Indeed, something is wrong. I forgot to actually assign it to rotation. That helps. So we have to come back in here. I do that a lot. I get all involved in doing the actual formula, and then I forget to put it in here. So we'll get it here, and we'll set this as our output node. And I bet you if we publish it out now, it'll actually work. There we go. So I can slow it down so it goes very slowly. What I can't do is reverse it. Let's take care of that right now. That's easy. Let's come back into our main graph. All we did was forget to change our defaults. So I'm going to come into my rotation speed, and I'll just set my minimum as -1. Let's make it 2. We can go faster, and we'll leave the default as 1, and we'll make the maximum 2 and the minimum -2. So we made our first little graph here, and that one's kind of easy because I mean we just made a simple spinny thing. With the next one, let's get a little bit more complicated as to what we're going to make. I want to be able to change, the size of the stuff that comes out of this effects map, and I want to be able to randomize this size if I want to. But I also want to be able to control how much smaller things get. So we're going to need to do actually 3 things. I want to be able to control how much smaller it gets, and I also want to be able to control whether or not it's going to keep its proportions. So what we really want to do is create the ability to give different inputs depending on what we want to do in the particular function where we're going to be dragging this snippet into. So again, let's come up here, make a new substance function, and this one I'm going to rename size, and I'm going to start dragging some stuff in here. Okay, we're going to need the number 1, and we're going to be making some random numbers between 0 and 1 for our sizes. Let's get a couple of those. And now if we were just doing, if we just wanted random size in either direction, we would do a random x, a random y, we'd get a vector float 2, we would set our size variable. Actually, I'm not in the effects mode. We're going to set the size variable later on, but this would be pretty much it. I mean, we're not seeing anything here because we're not applying it to this image, but this is going to give us a random number on the x and a random number on the y. But those random numbers are going to run between 0 and 1, and 0 is, like 0.01, which would be the smallest number you could find. There would be like a really small number, and I maybe don't want that kind of size discrepancy. So I want to take care of this size minimum first. And to do that, I need to be able to compare the sizes of what's coming out from here to a number that I'm going to designate. So we need 2 of those, and we need to create an input parameter in our function that we're going to call our minimum size. So if I set my minimum size to 1, they're going to be full size. Because if this number is less than my minimum size, and that minimum size is 1, it's going to cancel out the randomness. If this is smaller than the minimum size, then I want my 1. Otherwise, I want this, my random number. Let's just make sure I got that right. Okay. I got a number between 0 and 1. If that number is smaller than whatever number is in here, then I don't want that small number. I want the number 1. Otherwise, give me that random number. And I'm going to duplicate this. Oh, I didn't need that one right here. And now we have our second random number. I mean, they're both doing exactly the same thing. Right, so that deals with sort of the floor of the actual sizes of things that we're dealing with. The next thing I want to kind of look at is, is it going to be proportional, or am I going to let it be random, like a different number on the x and on the y? Get a couple more of these. And we are going to have to create another input to tell it whether or not it wants to have it be square or not. So let's come back in here, and we want a Boolean in here. So let's call this square, and we'll get Boolean. We're going to set it as a Boolean first. So we get square. And what we need to do now is set up our 2 possibilities. If something is square, Whatever number is coming out of here, I want it in both spots. Otherwise, I want one from here and one from here. So square is up here where this random number is the same number for both the x and the y, and then I have two random numbers down here. Right, so if square is true, which is our first one, we want this. If square is not true, then we want this. So that's going to take care of whether or not stuff is proportional. And finally, like I said, I want to be able to add any kind of animation I want to this. So I've got to find another variable. I got to find another slot where I can put that in on top of all this other stuff that I've done. So I'm going to start with a new input parameter, and I'm going to call this anim input. And let's get that out here. And my anim input is going to be a float one. I mean, it's whatever it is, whatever I'm going to be putting in here, because it's an animation, it's going to be running along a timeline. So that's a float one. Right. What am I going to do with it? I am just simply going to add it to whatever is coming out of here. So we have to add it separately to each random number. But other than that, we're just kind of laying it on top of what's coming out of here. So we're getting a random number. How we're parsing our x and our y's is coming in at the end. But before we do that, we're taking this number and just adding a timeline to it. And I'm just going to hold down the shift key here and just move that stuff. Again, hold down the shift key and move that. And that's just going to slot that stuff in there. And then this is going to be our output node right here. We can clean the rest of this stuff up. So let's see if this works. Oh, I forgot to I'm going to rename this FX size because otherwise I get confused. So here are those inputs that we created. Now, I think this is a good moment to just take a look at some of the sort of nitty-gritty technical aesthetic stuff. If we come back into, so like remember how these are. If we come back into our size here, this is where like groups can apply. So if I move this up, this order will change. Assuming there's no groups, it's going to do it exactly as you see it here. Otherwise, it's going to do group first and then within the order that you set. So come back in here, you'll see that the order that they're in here changed. And if we do it once more, we'll call this the size group. You see how it's drawn like a little circle around them? So they're like grouped together here. So that's how that stuff is reflected in the actual nodes that you see. We're going to get another one of these sequencers. Put that in there. And let's leave the anim input alone for the moment. We'll just call that a 1. And then, actually, we've got a whole lot of 1s here. Let's do that. Oh, I forgot to say, I keep doing that. Oh, we haven't actually assigned anything. Let's set a variable, and we'll call this size. It seems a little large. Let's take a look what's going on in here. Oh, you know why? Because I don't really need, I'm adding that 1. That's what I'm doing. I really don't need to add anything to that animate, the way it's set up, because I'm not multiplying. Yeah, like if you're getting something to animate because you're multiplying it by something, then you cannot have the number 0 there. But we are actually adding in this case. So we can have the number 0 and it doesn't, it literally doesn't change anything. But adding the number 1 adds the number 1. So we now have them at the correct size, but our square is false because by default this is false. So if we add another node, a Boolean, and we change that to true, they're all square now. Okay, so finally we are going to do our offset. So I'm going to come back up in here, new function. Let's rename it offset. And again, we're going to have two parts. We're going to have the regular offset. So again, we want some random numbers. We want one for the x, one for the y, and we're going to vector this into a float 2. Now, I want to be able to not just have the number 1. I want to be able to have an input that's going to allow me to change the distance that they offset. So we're going to come in here. We'll do offset distance, and we can add it in here. And we've got the basics done. So let's come back into our color luminosity. We can get our offset in here. Let's set a new variable, and we'll get another sequencer, and let's see what happens if we plug the number 1 in here, and there it goes. But I want to be able to adjust this from the actual graph. So I'm going to come back into my switches graph, and I'm going to add a parameter. Let's give it a different name. We want to keep unique names here, so let's call it sun offset. And we'll go ahead and grab that one up now, and we'll plug that in there. So now we're going to be able to adjust the distance of the offset. So our offset distance, and if we come back in here and fool around with this, hopefully it works. We're not. Ah. There we go. Not quite sure what happened there, but it's fixed now. Okay. So that's the first part done. It's offsetting, but there's really no way to animate it. And besides, I want to have the mechanics for that in here. So what we need to do is we need to go back to our offset, and we have to fix it so there's an input in here which will add an animation for us if that's what we want. Because again, it's something that we can reuse. So if we don't want an animation, we can just use this one. Otherwise, we've got to put something else in here. Unlike the size one, I'm going to use a multiplication here just because when I was fooling around with it, that's what worked best for me. And just like the other one, we're going to do this once for each random number. But because we're dealing with multiplications, we have to account for whether or not the number 0 shows up, because this will work as long as we're not multiplying it by 0. Otherwise, everything just disappears. So let's first start by creating our animation input. So it's going to be a float 1, because whatever it is, it's going to be on a timeline. And we'll call this our animation input. All right, we don't really need a group. And let's grab that up. So we're going to be, if this number isn't 0, so we're going to need an if else, and we're going to need to compare it to 0. I mean, you could do not equals if that's what you want. I'm going to do it this way. So if the animation input equals 0, then I want the number 1, because I don't want this to be 0. Otherwise, whatever float 1 is coming out of here, and it's an animation, so it's running along a timeline, that's what I want. So if this animation is turned off, it's turned off to the number 1, not to the number 0. And then this is the value that I multiply against my random numbers. So if there's no animation going on, it doesn't change a thing. But if it is, it's going to multiply whatever's going on here. So let's come back here. And we've got this new animation thingy going on. So right now it's 0, and we haven't started doing anything yet as far as making this stuff move around. And we're going to keep it like that. And let's just publish this out for now and see if it still works. Oh yeah, we have the rotation on, so we do have some sort of animation here. And there's our offset group. And as we move that number down to 0, it stops being offset. So we can choose how even we want them spaced. All right, so far so good. So we can have it rotating in one direction, we can have it rotating in another direction, and we can start getting the distances between them to randomize. Okay, so that's this stuff done. That's those functions that are external functions, and we're going to be able to reuse these in other things. But what we've also created for ourselves that we haven't even really touched on yet is all the potential animation that we can now add into what we've got going on here. Okay, so let's start with the offset. Now, I promised we were going to use waves, which is what I've got here in my library, and we'll pull this one out. And let's talk about, for a minute, exactly what this wave does. We can always see how it's built by opening up the reference. And it's got its own timer, and it's just basically running it along, it's doing a sine curve. And there are other kinds of curves inside the library that you can also use. So if you want to start building your own wave machines, you can use this as a template, and you can start using other waves as well. There's really no point for this, so we're just going to go back to our main graph. Close this. Actually, we want to go back to our effects map. So we've got this wave here. Now, it's got three things going on here. It's got an amplitude input, which tells you how high that wave goes, and it's got a frequency input, which tells you how often it goes up and down. Greater than 0 means it's all happening above 0, because you've got your x and your y-axis, and the wave is falling through the x-axis. So what it's doing is it's going from positive to negative, back to positive again. And by checking this, you're keeping it in the positive. So we've got that done. Now, I want to animate my little suns. So I'm going to use this wave to do it. And I'm going to have to create two new inputs in my regular graph to handle the inputs from my wave. I mean, I could plug in, if I just want to plug in a number, like for the frequency, I can do that as well. But if I want to change how quickly they happen, it's got to have its own variable. So let's come in here and make some variables. You know what, I'm going to be lazy. I'm going to copy this and paste it, and we will call this sun offset amplitude, and we'll just add that here. And let's make one for frequency as well. I'm going to copy this. Let's set the frequency, I don't know, to 1, and then our amplitude will set to 1. Okay, so we have to decide where we want to set our maximums for this amplitude. I'm going to set it to 2. You could set it however you want. It's saying how far in a given space of time, how far away from the middle of the x-axis is that wave going. So 2 is going to give me a much taller wave. So the bigger this number, the taller my wave. The bigger the frequency number, the quicker it goes. So let's set the frequency to 2 as well. And, feel free to make that how you want it to be. Let's bring those in here. All right. All right, so here we are. We've got our offset set in, and we can move that still. And if we turn it on, our animation is running, our clock is running, the rotation's happening. But the minute we start bringing it above 0, it starts its own animation. So this offset animation that's working on a wave is starting to, come in. And the extent of that swing we can increase or we can decrease it so they're moving just a little bit. And if we want them to move faster, we move that number up. So between these two, we can actually get these stars to move as little or as much as we want them to. More or less on a grid. I'm going to bring that amplitude down. We'll bring that offset low. So, you know, it looks kind of like a grid where it's just shaking around a little bit. So this gives us a lot of flexibility in how we move it. But the important thing is that the way we have it set up now, the minute we kick this in and give it any kind of frequency at all, the animation works. All right, so that's one way we can use a wave. And we can go ahead and kind of do the same thing to the size. We've got our minimum size here, but we can also create this same idea for the size, so we can have them get bigger and smaller according to the same idea, you know, of this wave, where it goes back and forth between numbers that we determine here. But obviously we need to make new numbers. I'm going to come back in here. We'll make a couple of new inputs. I'm going to copy this one. I'm going to paste it, except now I'm going to call this size. I don't know if we want those sizes to go up to 2, but there's only one way of finding that out, and that's to test it. So we can just highlight this and just change its designation and plug it right in here. And we can publish it out and see what it looks like. Okay, I'm going to turn this rotation off because it's driving me crazy a little bit. Let's bring this down to 0 so we can see what's going on without things wiggling around too much. All right, that's 2. I want to see, okay, so that's our regular size, and it's going to go below that number and above that number by this amount. So our initial size acts as the 0 point on that wave that goes up and down. So again, if you set the amplitude real slow and this up, you know, they're just kind of throbbing a little bit. That, and then we can get them to rotate a little bit, so they're getting a little bit smaller and a little bit bigger, and then you can do all the offsets, or you know, you can go crazy with it. All right, so you know that's essentially the same thing, but that's one way of using a wave. You can use it to literally move things around. Because a wave is by default just running from 1 to -1, and it's, you know, keeps switching direction, you can use it to do a lot more than just move things around. And I'm sure you can come up with your own creative ways of doing it. But one example we can use is to come back here into our main graph. Let's get a gradient map and throw some color up on here. Pick some nice colors. I find it distracting without the black background. And we're going to cut that out later, but just to look at these, it's easier. I'm not worrying too much about any of this. I mean, let's take a little bit of time to make some pretty colors here. Right now, what I'm going to do before I do anything as far as levels, nodes, or manipulate it in any other way, I'm going to adjust the global opacity here, because if you'll look at it right now, what's coming out of this effects map is, you know, it's not really using a lot of the white, so only where they're piling up on top of each other. So let's set this up to something bigger. That's probably too big, but this gives me some more color variation in what's going on in here. And, you know, obviously we're not going to stress too much about it because we're not really making a material that we're going to use. It's just an exercise. So as long as the colors aren't making me throw up, I'm going to be happy with them. I don't like that red. It's kind of making me want to throw up. So I'm just going to change that. I just double clicked on that point and it opened it up. Probably better. Maybe make this a little bit more orangey. That's better. Okay. Now, the thing that we made, I mean, the thing that I demonstrated where we're letting it pulse through a certain amount of color, automatically. So if I put this HSL node here, it's going to allow me to manipulate the colors. And I don't have to go through the whole range. I mean, first of all, this is only really going through from here to here, or from here to here. So that slider is, by going from 0 to 1, you're actually going through it twice. So what we're also going to do is we're going to cut that slider in half when we make our input parameters. But beyond that, I'm going to decide how much of a pulse I want. In my original example, I think I used like like going from 0.5 to 0.6, so it's like 0.1 is the difference. And I think that's a good number. You can make it smaller, you can make it bigger, but I'm going to stick with 0.1. So I want my wave, instead of going from 0 to 1, I want it to go from 0 to 0.1 and then back. So I'm going to create an empty function, and we can get a wave. There's a couple of different ways to slice this. Well, I mean, we end up having to put out the same amount of constants though. Right. I want my frequency to be 1, and I'll just make this 0.1 in here. We could also do it like this and then multiply it by 0.1. It gives you the exact same result. Actually, no, your frequency changes. So let's do it this way. So we've got our oscillation going by 0.1. We can think about changing the frequency later, but so that wave is really pretty shallow. It's just going from positive 0.1 to negative 0.1. But we want it to be going from a certain point. So that means we want to add a number to it. Well, I don't know if we'll be able to see it right now, but yeah, we can. Okay. So this wave is, we can't see what's happening with this animation, but this number here that we're adding to whatever that animation pulse is going to move the starting point of this oscillation. And that's what we want to replace with our variable. Oh, you know what? I just realized I did this only on the background in my initial thing, but that's cool. We'll do it on this too. Okay. So we will call this, we're going to make a new group, and we'll call it star color, and we'll call the group color. Now, the one thing that we still need to do is to cut the size of the slider that we're using in half, because I don't want to cycle through stuff twice. And that's pretty easy. All we need to do is literally multiply it by half. And let's take a look and see how our variable works. There it goes. But it's not cycling through it twice. It's just starts here in the same spot, but it only does it the one time. Alrighty. So let's see how that looks with the animation. We turn that amplitude off, and they stay in that same spot according to this offset. And we can change that. But that color is pulsing. That's really what we're looking at right now, because that's the only thing we added. So it'll look a little less ugly. So it's cycling through the colors, and we can actually have them change. But once we set that floor, it's still pulsing. We're still changing colors, but we're telling it where to start and finish the color change. And that's another way of using waves. Okay, let's work on the background now for these stars. And for that, we're going to get a couple of noises. And I'm going to animate this one. On the disorder, I'm just going to do something super simple. We're going to get a timer, and because I know it's fast and I kind of tested it already, I'm just going to take that and multiply it by 0.1, and that's just going to slow it down, and that'll take care of the disorder for these Gaussian spots, or Gaussian noise rather. Now I can also apply the same idea to something that we've been using so far with these other functions that we have, to the scale here. And again, I can have it pulse between sizes. And I'm trying to decide what I want here. So I think I want to have it go from probably like to maybe 3 to 5. So that's 2 spots beginning with 3. Let's see how we can make a wave do this. We'll start with a wave. So we said 2 spots, right? Okay. I'm going to plug it into the frequency for now too. We might want to change that later, but for the sake of simplicity. And we'll get an addition node. And we said we wanted it beginning with, I don't even remember, from 5, no, from 3 to 5. So I'm going to put another constant in here for the sake of explanations and to make things just clearer. So this amplitude means that the wave is going to go above 0 by 2, and then it's going to dip down below 0 by 2. It's going to change direction, and it's going to do all that. So that is actually going to change this here for us right now. So it's like 1, 1, 2, 1, 2. So that's what that wave is going to do. But we want it to start at the number 3. So we're going to add the number 3 to it. However, the expected output here is an integer. It only runs through whole numbers. And the wave needs floats, so it's easier to do this whole calculation in floats, and then just at the very end, we're going to cast this to an integer. So make sure I've got the right one highlighted here. Yeah, so we've got the scale and disorder functions done here. Let's get another gradient map, throw some colors up on there, something that goes with our purples. Let's maybe start with something blue. We'll get it all matchy. We'll fine-tune it later, but I think that'll do for now. And let's get another one for here while we're at it, and we can change the colors a bit. So we have 2 completely different backgrounds now. I'm going to leave this alone for now. I just want to hook this up because there's more I want to do to this. So I'm going to put that on top of there, and I really want to cut it out according to what's going on here, but there's way too much gray here, and we're going to have to fix it so that it's just black and white. I want to see whether, I mean, we can do it a couple of ways. We can use a levels node, but I think we might, quantize might work better. And what that does is basically cut down the number of grayscale point, I mean, like the kinds of gray that you have down to everything from like full gray, 256, down to 2, which is the minimum. So that only does black and white. I don't like that. We'll use a levels node because it's counting those grays as black, and I'd have to run it through a gradient level. It's cheaper this way. It'll do a good enough job. And we'll just turn everything to white. Let's see what happens when we do this. So that background is changing shape. It's animating. I'm not sure it's actually, yeah, it is. It is. It's probably a little bit too subtle. I'm going to change these numbers a bit. Let's make this oscillation 3 instead and see if we don't like that better. Yeah, I think that's better, and I think I want it smaller overall as well. So we're also going to make this, let's make this 5, see if I like that. Yeah. And at the same time, they're moving. So we're getting some variation on there. The colors could use some work, but the animation is good. All right, so we can take these 2 backgrounds and we can use a wave to switch back and forth between them. And I'm just going to go into the opacity. I'm going to make an empty function. I'm going to come in and get another wave. Now, I'm going to go ahead and set this up as the output node for right now. And let's see what happens. So that background is switching, but it's spending much more time on that yellow one than it is on the blue one. And there's a very simple reason for that. And there's also a very simple fix. As this wave, it's going from 1 down to -1, back up to 1. And if we get another blend node in here, and I put in -1, it's counting it like a 0. So it's actually spending twice as much time on 0 as it is on 1. So I'm going to come in here and I'm going to go into function absolute, and I'm going to get the absolute value of whatever's coming out of this wave. So it'll always be positive. So even if it's negative, it's positive. And now if we publish this out again, we're going to get an even split between the two, because it's reading that -1 as a 1 instead of a 0. Those colors are kind of ugly, but honestly, I don't really care. We can fix that at the end. So that is another way of using waves. And we're going to go through one more thing that we can use a wave for before we actually fix this material to look like something. And that is going back to our effects map here and looking at our rotation. Okay, we can use a wave also like a switch. I mean, up until now we've been just, using whatever is coming out of here directly. But we can also have it do something like switch the direction of our rotation. So let's get another wave here. Before we start, let's come in here. I'm going to make a frequency for that switch, and we'll put this under rotation. So yeah, we're still going to use a float one, so we can just copy that. Saves me having to put the group in. And we'll call this switch frequency. And I don't know, let's make it 5, whatever, it doesn't really matter. Right, okay, so the default is 1, we've got a max of 5, a minimum of 0. Let's come back in here and let's grab that up, and we'll put that in the frequency. The amplitude will have as 1. Okay, so like we've been saying this whole video, it goes from 1 to -1, back to 1, back to -1. And as it's doing this, it's passing through a bunch of different numbers. So we can always use the numbers along that trail that it's traveling to set up logical statements. Or in this case, a conditional statement, I should say. Okay. Where comparison? If it's... And this is only an example. I'm just doing the simplest example of this, but you can get as complicated as you want with this, because it's traveling through float values. So it's going all the way from 1 down through 0.99, I think it's like even 3 decimal places. So you have pretty much an unlimited amount of numbers, of float numbers, that you can use to set up all kinds of stuff. But for now, if our wave is above 0, we're going to have it just do the rotation speed. Otherwise, we're going to do the negative of the rotation speed. And that's just like a super simple example of what you can do. But it's a really powerful way to get switches to work, because you've got like a whole plethora of numbers, and they can interact with each other. All right, let's publish this out, see what it looks like. Okay, I'm going to shut all this stuff down because there's too much to look at. Oh, we forgot to put it in a group. It's up here. Okay, so if the way we have it fixed here, if we have this at 0, we have no rotation. But if we set any kind of rotation in here, it starts to switch direction according to how high I set this. So it's gonna switch a lot quicker. In fact, we've probably gone too high. I think it's beyond what it can handle. So I think probably 3 is probably a better number for that frequency as far as the top number. But also, if we set the frequency down to 0, it shuts off the wave, and then we can manually change it like this, because we're sliding through negative numbers here. Because all this is doing, it's taking whatever number is in here and it's just flipping its positive and negative numbers according to a certain frequency. So it doesn't really matter if you start with a negative number or positive number. It's just going to flip them. So before we forget, let's come back in here and set that maximum. I'm also going to move this up next to the other rotation. Oh, we forgot to put, oh, that's why, because neither one of them has a group. Okay, so let's call this rotation. So I think that's the functional mechanics of this material done, but it's kind of ugly. So let's take a little time to beautify it. I'm going to start with these gradient maps. That's better. And we'll take a look at this one, and we'll kind of do the same thing to it. It's starting to look more 60s. Let's take a look at that so far, how that animates. That's a little less ugly. Yeah, I'm not overly worried about this. I just don't want it to be completely lame. Let's get some normals happening on here. I think I'm going to fudge this. I mean, I really don't want to set up a whole new thing in here. I mean, because this is the blend right here that's going to be changing. I don't want to have to repeat this entire thing in black and white. So what I'm going to just do is cheat, and we'll just take whatever normals come out of here, because it'll match the pattern. Again, this isn't a material you're actually going to use for anything. Maybe soften this up though. And we'll get a blend, and we'll use this mask. And we can get one of these. It's kind of expensive, but I don't think I have the height set in here. I honestly don't know how much that helps the overall material, and that's a far less expensive way to do it. Because the background's kind of subtle, so I'm going to leave that. Roughness, I want this stuff shiny, so we'll do it directly off of here, and we'll just grab a levels node. And metallic, I'm going to just invert that mask. Yeah. So we've got all of this stuff set in. I'm going to test drive it one more time, but I think the lesson is over. I mean, you know, this is a very woodstock material. I guess we can use it for something like that, but beyond that, I can't imagine what you would use this for. Yeah, okay. Yeah, I like that better. All right, so I think we're done. It's weird, but I hope we learned a lot about waves and nesting functions, because it gives you a lot of flexibility, a lot more flexibility in what you can do with stuff, and it lets you reuse stuff. So I hope that's been helpful, and I will see you in the next video.